Welcome to Aksharashala. In this video, we are going to discuss about transistor Miller time-based generator, transistor bootstrap time-based generator, and the difference between Miller and bootstrap sweep circuits. This circuit represents circuit diagram of a transistor Miller time-based generator or transistor based Miller sweep circuit. It consists of a switch. Here transistor Q4 acts as a switch, and one RC timing circuit, and it consists of a three-stage amplifier. To have a better linearity, it is essential that a high input impedance amplifier can be used for the Miller integrator circuit. Hence the first stage, this is the first stage of three-stage amplifier. First stage of the amplifier in this figure is an emitter follower. This is emitter follower. The second stage is this is the second stage. This is the common emitter amplifier, CE amplifier, and it provides the necessary voltage amplification. And third stage is again emitter follower. Third stage is output stage, and it is also again a emitter follower for two reasons. The characteristics of emitter follower is it has high input impedance and low output impedance. This low output impedance R0 is useful for driving the loads such as horizontal amplifier in CROs. Generally, output of this circuit is a sweep waveform or a sawtooth waveform, which is used as an input to horizontal amplifier in CRO, which controls the motion of electron beam. Second, because of its high input impedance. Because of this high input impedance, it does not load the collector circuit of. Because of this high input impedance, it does not load the collector circuit of second stage, and hence the gain of the second stage can be very high. So second stage completely acts as a amplifier. Its gain will be more if we use a emitter follower in third stage. Operation of transistor Miller time-based generator. It is a simple circuit. So capacitor charges through VBB with a time constant RC, and it is connected to the output of Q3. In this way, sweep voltage is developed here. When it at the end of the sweep, it discharges through diode D and emitter of transistor and R1 like this. This point is emitter of transistor Q4. Now let us discuss about the transistor bootstrap time-based generator. This circuit is a transistor bootstrap time-based generator. The input to transistor Q1, is a gating waveform. This is generally output of monostable multivibrator. Output of monostable multivibrator is used to get the other circuits like this, and it is equivalent to this voltage. In this way, a linear output voltage, sweep voltage, generates by using bootstrap circuit. VCC by R, and the emitter current of Q2 is VE by RE. So how formation of sweep? How sweep will be formed in this circuit? Let us see. When the negative going gating waveform is applied at t equivalent to 0, then what happens? Transistor Q1 will be in off state. Then this circuit will be disconnected. Then if you neglect to drop across D1, current flows in this direction. Then drop across R1 is VCC only. Then I1 is given by VCC by I1 equivalent VCC by R1 only. When this current flows through capacitor C1, it makes a drop across capacitor and is given by 1 by C integral IC1 dt. So 1 by C integral IC1 is given by VCC by R dt. VCC by R, it is a constant, take it out. VCC by RC is taken out. Integral of dt will become T. So this is just like Y equivalent mx. It is a constant waveform which passes through origin. So this is, in this way, sweep voltage, a voltage which linearly increases with the time, is developed in the circuit. Now let us see the difference between Miller and Bootstrap sweep circuits. Miller sweep circuits and Bootstrap sweep circuits. Here Miller circuit consists of negative feedback, whereas Bootstrap sweep circuit consists of positive feedback. Output of the circuit generates negative ramp. Here output of the circuit generates positive ramp. It requires amplifier with very large gain. It has emitter follower with unity gain. High input resistance is not necessary for the amplifier. Here higher input resistance is required for the amplifier. These are the basic differences between Miller and Bootstrap sweep circuits. For any queries, please contact aksharshala@gmail.com. Thank you. For further updates, please subscribe to Aksharshala.